So here I can say that the distance from A to B is, let's say, 3D. And that makes the case of Bimmel easier because he is taking each one of these modes for d kilometers and d kilometers. So the time it would take for each of these legs would be distance divided by the rate. So d over 10 plus d over 20 plus d over 30. So that's the time taken by Bimmel. Now I need to do the same thing for Hummel. And he takes for 1/3 of his total journey time. So total distance is 3d. So if t is the total journey time, then he's doing t over 3, t over 3, and t over 3. So that means that the distance he would cover, if he were to travel by this mode, would be the rate times time. So 10t over 3. Same thing, plus 20t over 3, plus 30t over 3. And that has to match 3d because that's the total distance covered. And so I can calculate t. I can factor 10 over t over 3, so that's 50, 60, and that's 20. So t is 3d over 20. Eventually, this is the total time that Hummel takes. Here also, I can just factor out a 10, d over 10, and then I just have to add these two, these fractions. So that's 5/6, so 1 plus 5/6, which is 11/6. So 11d over 60 is the time that Bimmel takes. Now we're asked percentage by which Bimmel's travel time exceeds. So Hummel's time is the reference. So that means 11d over 60 minus 3d over 20 times 100. You could pick numbers here too, but sometimes I think it's easier. I get confused with numbers. So multiply this by 3 over 3 so that the denominators match. That would be 11d minus 9d over 60 times the reciprocal of that. You'll see the d will eventually drop out. We have the 100 too. So that becomes 2d. I tend to write it multiple times just to make sure I don't make a mistake. The d drops out. That goes away. 2, 3. So I get 2/9 or 200 over 9. And I can just do the division or use the calculator. 9 times 2 is 18. 9 times 2 is, so it will be 22.222. So closest is choice A, 22.